Good evening, everyone. So, tonight we're going to be going over some more Excel questions. This time on project appraisal. Last time we did a loan schedule question, which I hope um, would cover the basis for or kind of the structure, the general approach to a loan schedule, and then you can go on and practice more loan schedule questions, different variations of loan schedule questions, more difficult ones, so that you can get the hang of it. And likewise, we're going to be doing the same thing with project appraisal. Just going to be doing one question, although I'm going to be adding some of my own questions and twists here and there to make things a bit more interesting so that we cover all our bases so that you can be able to practice project appraisal questions in Excel with confidence and you can hopefully get that FinMath exemption. So, without wasting a lot of time, let's go. It says that a finance director wants to implement one of these two projects or one of the two projects and has asked you for a recommendation. You, being the actuary or the actuarial student with knowledge about present value and the theory of interest, which is what FinMath is about, need to give this person who's a finance director a recommendation. It seems like there's information missing here because there is information missing here. I cut this question out from an exam paper. I think it was September 2022 CM1B with the Institute and Faculty of Actuaries. You can find it online. But I just cut out the part that I wanted to go over. But we still have the information here. Project. So the two projects that we're meant to choose between is Project A and Project B, which we have all the information for them here. So the question says the company has a policy of using an annual effective target rate of return of 6% per annum. So we have that I. Immediately we have that I. No, it's late, so I'm going to be making a lot of mistakes. Forgive me. So I is equal to 6%. Oh my goodness. 6% per annum, like this. Already want to write down our information. Like I said in the previous video, you usually want to write down your information in a place that's easily accessible so that you can reference it throughout. So want to determine the NPV for each project. Okay, for each project, I'm just going to, should I do it? Um, yeah, I think for each project, I'm going to do the NPV uh in the separate sheets. So I'm gonna put this here, and then I'm gonna remove this. Clear the contents. I'm gonna put I is equal to 6% per annum. It's just easier for me because all the information is already put nicely for me here rather than me having to switch between sheets every time. I can just work within um, the sheet that the information is already in. Okay. So for project A, we have that the objective is to streamline the finance processes, resulting in a cost benefit through a reduction in finance staff. This is a 10-year project, so the term already it tells us that the term is already 10 years. Oh, 10 years. And the costs in year one we have 1,500,000 for implementation, setup, and testing. From year two onwards, we have 100,000 annual maintenance costs, which are fixed for the duration for the project. From year two onwards, we have 100,000 per annum on staff saving realized each year going forward, and these savings increase by what? By 0,005 each year through the contractual staff salary increases starting from year three. And from year three onwards, we have 350,000 per annum of additional staff savings realized each year going forward, and these savings are increased also by 0,005 each year by contractual salary increases starting from year four. Okay. Um, I just want to see if we have all the information. Okay, we have all the information that we need. So the first things first, I want to highlight this so that it looks nice. I like bright colors because I still have the whimsy in my life. We're gonna draw a timeline, or we're gonna have our time column. So time is, we're going to start. So there's no need to start from time zero here, or we can out of just convention because we usually like to include zero, except maybe during a loan schedule, which makes it kind of iffy as you saw in the previous video. But I'm just gonna include time 0, 1, 0, 1, 2. But there's no need to include it because everything starts from first year going forward up until time 10. That's our time column. And then I'm going to start with the initial cost. So initial cost. The initial cost is 1,500,000 in year one. And so in year one, I'm going to assume that it's the end of year one here because it doesn't really say the end of or the beginning. So I'm just going to say that these imply the ends of those years that this is talking about. So this will be end of year one. So this is what I was talking about, that there's no need to include time zero because we're starting everything from the end of year one here. So this is our starting point. Uh, I'm going to delete this cell even though it hurts my spirit to do this. Okay, now look, it's gonna be a long night, man. Shift everything upwards. Okay, cool. So here, the initial cost, we have 150,000. I'm gonna fix that, which is FN F4. Oh, 1,500,000. And additional costs or maintenance costs. So I'm gonna have a column for this. So when you're answering questions in Excel, there is a temptation to do this like you would by hand. And by that I mean instead of doing all these columns here, you just come into a column and then write down the formula for an annuity in advance plus or minus or plus an increasing annuity minus a geometrically increasing annuity times force of interest, some weird stuff like that. So, right, the temptation to write out a long formula in this box to get an answer, which is kind of gutsy because you can get the correct answer, but if there's the tiniest of mistakes, then immediately you get zero. Because usually, how a memo for an Excel test or exam is set out is that whenever there's an item here or a stream of income or cost or whatever, for example, here we have one which is the savings, additional savings cost, additional maintenance cost. Each column has a mark allocated to it. So that's how you get part marks in Excel, by doing things column by column, step by step, and slowly. And it's usually more accurate that way because you're less likely to make mistakes rather than punching into a single formula box, such a long formula, and getting one thing wrong and ending up with the wrong answer. Plus, I don't know if we're allowed to mark answers of that nature. Usually, we're encouraged to do this. And also, we can't use Excel function like the PV functions, which returns the present value of investments. And also, I don't think in most cases this won't work because in FinMath, because they love making your life difficult, rates will change, uh, timings will change, payments will increase or decrease or whatever. And this thing works with flat payments and rates. So it'll be difficult to get it to work for the type of stuff that we do in FinMath. So just keep that in mind. So maintenance cost starting from year two onwards. So it's going to start here. I'm going to put a formula here and it says 100,000 annual maintenance costs, which are fixed for the duration of the period. So we have 100,000 flat. So I'm going to put an if statement just because I like if statement. If the time is greater than one, so that it starts at the next time greater than one, which will be two. I want you to put 100,000 And if it's not greater than 1, just leave the column blank. And it's going to leave the first one blank, but from 2 onwards, it's going to put 100,000. Now, I didn't need to put this if statement. I could have just copied down 100,000 from this cell downward. I just did the if statement just because it's good practice to know how to be able to do things like this um, automatically, or how to automate stuff like this, how to put a formula that deals with the nuances of timings and everything for you. So instead of looking for the column that corresponds to time 2 and punching in a formula here and taking it down, I can just put in one formula here that takes everything into account, all the changes, whatnot, for me. So yeah, it's good practice. Learn to use if statements. They're really helpful and they save you a lot of time. So be creative when you're answering these questions. So those are maintenance costs, and now we move on to savings. Savings. And so we're gonna have core savings, staff savings from year 2 onwards. So it starts here 100,000, and they increase by 0.05 each year. So starting from year 3. So the first increase will be here. So we'll have 100,000. What am I doing? 100,000. I'm gonna fix that by pressing FN4 times 1 plus this rate here. I'm gonna fix it as well because I don't want it to change. And I hope it's compound increasing by this rate. Yeah, it is compound increasing to the power of, I'm gonna put, hmm, the first one here, I want it to be flat 100,000 because the increase starts here. So I want this first one to be to the power of 0, and I want to use the time column to do that. So I'll say to the power of this minus, you can either say minus 2 flat like this, or you can reference the cell that has 2 in it and fix it while this one changes. And so what's going to happen is voila, and it'll say F4 minus F3, F5 minus F3, F6 minus F3. Or you could just save yourself some time and just put 2. It's the same thing. It won't make a difference. I just like referencing cells instead of putting numbers and hard coding numbers into my formulae. So those are your core savings, and we have additional savings. Additional savings which start from year 3 onwards, which are 350,000, increasing in the same way as the previous savings. So I'm going to put a similar formula times 1 plus the rate of increase fixed as well, to the power of, this time I'm going to say this cell minus this cell fixed, because it's the cell containing F4, but I can feel the anxiety of some of you through the screen because I referenced the cell here instead of just putting a 3. So I'm just going to put a 3 to ease your nerves a little bit and calm you down. And then we're going to do the satisfying drag. You know what? This time I'm gonna do it like this. And then I'm gonna press Control D to drag my formula down like that, which I find very satisfying. What else? And that is it. So now, after all those items, we can have our discounting factor, which is equal to 1 plus the interest rate fixed to the power of minus the time that we're at. And again, I'm going to take this down and press Control D so that it drags the formula down. And then, okay, what you can do, I'm very lazy, so I'm going to tell you all the ways that you can do this, and then I'm going to do it the way I want to do it. What you can do is that you can have a PV initial cost column, PV maintenance cost column, PV savings, and PV additional savings. You can do this. it's probably good practice to do this. And what you do is that whoa, you multiply each item here by the corresponding discounting factor like this. And then for the maintenance thing, you do the same thing. You multiply it by the corresponding discounting factor. Yeah, I should have said put zero. So because Excel doesn't like working with blanks. The problem why I'm getting a value error is because I put a blank here and a blank is a string. It's not a number. So it's multiplying the string by a number, which is weird, and it's getting a value error. So instead of a string, if I put zero here, it'll give me zero. And do the same thing here where I multiply the savings by the discounting factor and additional savings by the discounting factor. And then after you've gotten after you've gotten all your PVs, okay, I'm just gonna do it this way. Just because I've already done it. Maintenance cost. I'm just gonna do it this way. And then for your end net present value, you're just going to say the sum of the incomes. So the sum of the savings plus the sum of the other incomes, which is the additional savings, minus the sum of the costs, which are the maintenance cost minus the initial cost, like that. And that gives you a net present value of 562,000 700 and something something something. What I will say is that what did I want to do instead of this? Um, what I wanted to do was to just do all of this immediately using some product. And some product would have done the same thing, essentially multiplying each column by the discounting factor and then summing them. But this way works as well. So um, I'm just investigating the discount factor here. Oh, and I just realized that in doing this question, I left out a crucial assumption, which is stated here. I'm gonna put it in bold now so that everyone can see it. It says that the cash flows occur halfway through the year. So it means this one does not, it occurs halfway through the year, uh, the second year, between year 1 and 2. So it occurs at time 1, comma 5. This one occurs at time 2, comma 5, 3, comma 5, 4, comma 5. Don't know why we made this assumption, but an easy way to adjust for it is to just subtract 0, comma 5 from our in the exponent for our discounting factor. So instead of just putting 1, comma 5, you can do that. You can just put 1, comma 5, 2, comma 5 here, but I'm gonna opt to do it this way, which gives us a net present value of um, which gives us 578 as our net present value here. And I'm just gonna highlight that. Well, I'm just gonna put borders on the entire table. So the net present value of the project is 578. So now we have the net present value of our project. We're going to do maybe two additional things to this problem to kind of modify it. What is our IRR, our internal rate of return for such a project? Remember, the internal rate of return is the rate of interest at which the net present value is equal to zero. So we want the net present value to be equal to zero. How do we find that? How do we get our IRR from this, knowing that our net present value is equal to zero? Well, the answer is that we use goal seek. So first of all, we're going to assume that there's something here. We don't know what it is yet, but we're going to assume that there's something here. And for our discounting factor, I'm going to discount at the IRR. which is C20 there. And there's nothing there now, so these discounting factors are just all going to be 1. We're just assuming that there's something here in this discounting factor column besides 1, and we're going to say, well, we're going to use goal seek. Remember, goal seek is like solving for a variable, and this time the variable that we're solving for is I. So we're going to use goal seek to set this net present value column to 0, because we know that under the IRR, the net present value is 0. And the cell that we want to change is what you want to solve for, which is I think the independent variable. Can't remember. So the cell that we want to change is this one, the IRR cell. So we put it in there and press OK. And goal seek will find the correct IRR for us, which in this case is 13%. 13%. And whenever you find a quantity using goal seek, you have to specify via goal seek, because there are other solver tools, I think, on Excel or other ways to solve such questions. So you always want to reference, I got this using goal seek. So that's how you do that. And another question would be, well, so we found our IRR using goal seek. I'm going to refer back to the original interest rate because I don't want this to have an NPV of 0. I want it to break even in between here. So I'm going to use the original interest rate again, C18. How do we find the DPP of this project? How would you find the DPP of this project? Remember, the DPP is the earliest time at which the NPV is greater than 0. So it means that you need the NPV at every particular time in Excel. So we have NPV at time t. I'm going to create this column. So this gives us the NPV at each time. So for NPV1, it's going to present value all the cash flows at time 1 to get the NPV at time 1. NPV2 is going to cash flow to present value all the cash flows before time 2, so time 1 and 2 to get the net present value at time 2. Time 3 is going to present value all the cash flows from 1 to 3, and so on and so forth. So we want the NPV at time 2 at time t, and the t at which the project moves from being negative, from having a negative present value to a positive present value. That's where our DPP is. So here our NPV at time 1 will have the incomes, which are the savings. So savings, PV savings, PV additional savings minus the expenses, some initial cost, maintenance costs. And that'll be our NPV at time 1. And to get our NPV at time 2, you just sum again your incomes minus your expenses, initial cost, maintenance cost. And then after that, you have to add in the NPV at the previous time. And then you get this again, which is weird. And then you just do that. You just do that for each time. And then you'll see, let me make this column also pretty. And then you'll see that the NPV at time t changes from being negative to positive between time 7 and 8. So it means your DPP is somewhere between time 7 and 8. And because Excel is discrete in nature, we can't explicitly find the DPP, like the exact DPP, like 7,45 something something. The best we can do is say it's in between time 7 and 8. So DPP is between time for T7 and T8. Cool. So we've covered 3 concepts: the NPV, which was the easy one, the IRR using goal seek, and the DPP using the NPV at time t. Other people use the accumulated value at time t, which is also a valid method. So instead of net present valuing from time t, you accumulate to time t, which is also a very valid method which you can use. But I like present valuing, therefore we are going to present value because that is what I like to do. Cool. So now we move on. It's getting very late. But we're going to move on to project B and quickly knock it out of the park as well. You guys should be able to do this on your own, but I will hold your hand through this and do it with you. So again, I is equal to 6% per annum. Okay. So the project B says the development by IT experts within business days of a finance administration system. There's a 15-year. Okay, I'm gonna make my assumption in bold before I start reading because I'm gonna forget it again. Okay, so this is a 15-year project with cost and savings considered over the 15 years. So again, the term here is 15 years, and I think the last one was 10 years. So we have in years. Yeah, it's fine. 15 years. Currently, the company uses a finance administration system provided by a third party provider. The company pays an annual fee of this to the third party provider for the use of the maintenance of external financial or finance administration system. The annual payment to the external provider increases by 2% compound each year, and the next increase is due in 1 year's time. The project will enable this external system to be switched off at the end of 2 years. Ooh, very interesting. The company will save the increasing annual fee that was expected to be paid over the remaining 13 years. And the cost will have in year one 500,000, in year two 500,000, from year two onwards 100,000 fixed. So similar thing to the previous question. Again, I guess not too difficult. But yeah, the assumption is again that the cash flows occur halfway throughout the year. So again, we start as we always do with our timeline. So 1 to up until time 15. I'm gonna drag this down to time 15, and I'm gonna move a bit more quickly now because this is pretty easy. It's very similar to the previous one, and I want to go to bed. And now we look at the project costs, which is 500,000 in year one. Fix that. And in year two, 500,000 again. Fix that. And then we'll have maintenance costs. So I'm going to put the maintenance cost in their own column just because they have a different structure and there's probably marks allocated separately for that structure. So maintenance cost starts here from year two onwards. Yeah, and we would have an overlap, so it makes sense to have a separate column. 100,000 maintenance cost fixed each year. Oh, it's I thought it was increasing, but it's fixed, but it's fine. Cool. That's our maintenance cost. And now we'll have our savings or profits, if you call it that. So remember that our savings only properly start after this thing is switched off after the second year. So for the first 2 years, you'll have a negative profit, but it's fine. So currently, the company, um, the company uses a finance administrative system by a third-party provider, pays an annual fees of 255,000 to the third party, and whatever. So there is a cost of the 255,000 that they're paying, but then after they switch it off in 2 years' time, then it becomes their savings. So this is when they switch it off. So okay, so we'll have 200,000 I'm seeing stars now. 1 plus 2%. I'm gonna fix that to the power of uh so the first increase is in a year's time, which is here, and I'm here and I want it to be 0 here, so I'm going to have to say this minus this fixed, like that. Should be like that. Okay, so this question is a bit vague in that they specified that we pay this 255,000 to the third party, but they didn't specify it in the costs. They didn't specify it in the cost, but we know that we pay it and it becomes an income after 2 years. So what I'm gonna do is that I'm going to leave out the part where it's a cost, which is the first 2 years, and only put in the part where it's an income because that's how they did it. I had a quick look at the memo, and that's how they did it in the memo as well. But it is a vague question, so it would not be unreasonable to have like a cost column here, or not even a cost column, but to have negative savings for the first 2 years and have positive savings for the subsequent periods. I think it's up to interpretation unless there's something that I missed here. But yeah, whatever. So now we can come to our discounting factors, and these are equal to 1 plus the interest rate fixed to the power of this minus 0.5, um because minus, so minus this plus 0.5. I have to shift it upward by 0.5, and these will be our discounting factors, I think. So this will be discounting factors. I shifted the discounting factor in the wrong direction. This is supposed to be minus, so that the first thing happens at time 0, 0.5, 1, 2, 5, etc. So shifted it in the wrong direction. And so now we'll have PV costs, PV maintenance, and PV savings. And in the last column, we'll have NPV. So net present value, where this is initial costs times discounting factor. This is maintenance costs. Just realized I misspelled a lot of things, times discounting factor, savings times discounting factor, and the net present value is going to be the sum of the savings. Ooh, of the savings minus the sum of the initial costs minus the sum of the maintenance costs. And we will drag this down so that it gives us a positive, hopefully, net present value of 544,000, which is the correct net present value. And there we go. That is our question. And so the one that you would choose, you would explain this in a very wordy way, in a very technical way, in a very comprehensive way, where you say a lot of English about how NPV for project A is greater than NPV for project B. But I'm not going to go through the crux of explaining all that theory. I'm sure you guys know and understand it very well, but I just wanted to cover the basis of how to use Excel for project appraisal. We found the NPV, the DPP, the IRR, and you can apply this to literally any other project appraisal question, and you should be able to apply it with ease, I would say. So you can do for project B, you can do the same thing we did for project A, where you try to find the IRR, for example, by going to goal seek and changing this to value zero by changing the cell that has the interest rate, which is this one, and it gives you an IRR of 13%, which is similar to the previous question. And you can have an NPV time T here to get your DPP, which I'm not going to do now. And yeah, you can apply this to any other project appraisal question. And that is how you do project appraisal in FinMath. So I hope you guys enjoyed the video. I hope you found it useful. And keep practicing, keep pushing more questions. This does come naturally at a certain point. It does get to a point where it's almost second nature to you, and you have a lot. It's very intuitive, but it all comes with practice. So you just have to practice more and more questions on Excel and be willing to adapt and be flexible and learn new ways of doing things, and you should be good. I believe in you guys. Keep practicing, believe in yourselves, and keep working hard. And surely, 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 at the end of the year, when we get those provisional marks, we will be there for the exemptions. Okay. Good night. Bye.